Welcome to our first video here from Chapter 11. This will be on the goodness of fit test. We're going to be doing some notes here. So first of all, looking at the goodness of fit tests to see if two distributions are the same or not significantly different. It might be, have they changed since last year? Could be, is it different in one place than another? But that's the idea. You are comparing distributions, as opposed to prior chapter there where we were comparing means. So with distributions, we're going to be using what's called a chi-square test. And so a chi-square score. And with that, we're going to be using a chi-square table. Looks like this, very similar to our t-table or any other table, but in particular the t-table because it has degrees of freedom, just like the t-table. All along there are our degrees of freedom. Over here are our different alphas. We're mainly going to be looking at these down over in here, in this area. Now, as we're looking at these with the degrees of freedom, and remember, we use the notation D period M, or degree period F, degrees of freedom. For the t-test, it was an n-1. For here, it will be a k-1. Where k is a number of classes. Number of classes. So we're going to do just a couple, just practice so that you can look at it, not knowing even anything but the fact that we're going to use k classes and find a degree of freedom and then a chi-square score. So for example, let's say we have 7 classes. And we have alpha equal to 0.05. Then for our chi-square score, our degrees of freedom, k-1 is 6. Now we go to that table that I showed you. Let's practice where we've got 7 classes and an alpha significance level of 0.05. Our degrees of freedom then being k minus 1 is 6. And going to that table that I showed you, finding our degrees of freedom is 6, and over across underneath 0.05. That gives us a 12.592 as our degrees of free, or as our chi-square score. So 12.592. And as we're looking at that, we'll be looking at a chi-square table. Score. It's not like the normal score. It goes out farther on the right. We would be looking at a 12.52, 592, and anything above there would be in that rejection region. So it's for a chi-square score, it's always and above for a reject. One more thing I want you to note is the test statistic. It's going to be longer than what we've dealt with before. It is a summation of what are called the observed values minus the expected values, quantity squared, over that squared. So neaten that up maybe one more time. Sum of the observed minus the expected, quantity squared, over those expected, observed minus expected, quantity squared. And we'll look at an example of that here in a little bit with the complete hypothesis test.